One of the emerging tool for data pipeline orchestration in the cloud is Dagster. In this video, I'm going to show you how to use Dagster with AWS EKS. Dagster is one of the coolest tool which I have seen in data engineering, especially which is faster, reliable, and scalable. Centra, which is a cloud data security company, is using Dagster with EKS with a lot of success. So this architecture which I'm going to show you is being developed by Centra with the help of AWS. As you can see in this architecture, Centra is using AWS Fargate for its external facing microservices and AWS EC2 instances for processing, service integration, and alerts. Because Centra is a security company with security as a primary concern, Centra is using Fargate because Fargate is out of box security isolation, because whenever you create a pod in AWS Fargate, each Kubernetes pod has its own isolation boundary and different pods don't share the underlying kernel, CPU, memory, or networking resources. And they are using Dagster, which is an open source big data orchestration framework to run efficient, scalable, and sophisticated workflows that require dependency and state management. In this solution, you can see that the Dagster control plane is on the AWS Fargate. Using Dagster and EKS, you can reduce the effort needed to run and maintain your data jobs. So the Dagster control plane executes Dagster jobs known as DAGs or direct acyclical graphs, which represent dependency trees. A DAG is invoked by a Kubernetes job that launches a run manager. The run manager takes care of the orchestration for a specific run. Each step in the graph is executed as Kubernetes job and perform the specific task, while together they execute a broader use case. These Kubernetes jobs run on AWS EKS self-managed nodes. By using self-managed nodes, it speeds up the process runtime because it allows provisioning of all resources required for a workflow at once and avoid wait time between the steps. So you can see that in this diagram, not only we are using EC2 but also the spot instances and also the Dagster. And Dagster especially allows defining different resources and configuration per step in the workflow, which are translated to Kubernetes request and limits per container. The resources required for all steps are aggregated and containers are scheduled into shared Kubernetes node managed by Carpenter. And Carpenter is an autoscaler. Carpenter terminates underutilized nodes, and when a step requires intense CPU or memory that isn't available for it, this can be met by quickly scaling up. With consolidation enabled, Carpenter looks for opportunities to reschedule workloads onto a set of more cost efficient EC2 instances, which is very useful for dynamic workloads when there are changes to the resources and the requirements of the application. So I hope that you found it useful. And so if you're running your data pipelines and data jobs, especially the big data ones on AWS, then I would highly suggest you look at this architecture and try using AWS EKS with Dagster and Carpenter to speed up your data orchestration and data pipeline jobs. If you have any feedback for this video, please put it in the comment section. Thank you.